了解。He's so happy. Good morning, everyone. Do you have lunch breakfast yet? No, yet. Okay. Today we are going to introduce how we control Arduino board and then turn on and turn off the air pump to control your soft robot. So, by the way, how about your soft robots? How about them? Are they good, bad, terrible? Good. Really? And there's some of the issues about the modes, about the repeating parts. Do you have them or not? Do you bring them here about your part modes? Nope. Nope. Okay, fine. So our TA, one of our TAs will introduce how we use Arduino board to control the air pump today. In the morning, right? In the morning. Okay. And then in the afternoon, you are going to try on your own to write some programs in the Arduino board and then control the valve. And if you still have time, please try to modify your CAD part files, because I believe some of you will print 3D part, create the 3D parts in the weekend, right? Probably. Okay. To kind of recreate your software robots. Okay. All right. So let me give him a microphone to our TA and let him introduce the Arduino board.
Okay, good morning, everyone. So I hope you have a good sleep last night. So today I'm Peter, and I'm going to be in charge of today's lectures. So I will give lecture about short introduction about electrical circuits and Arduino board today. So let's get started. So here is our contents gonna learn today, which have a short review about what we have learned with other professors. And secondly would be electromagnetic valve, which we use it to pump our air to our soft robot. And next to relay modules. And lastly, fourthly would be electrical circuit, and lastly to Arduino programming. So let's have a short review. So do you guys still remember when you study with Professor Nakashimoto about air pressure and liquid pressure? Can you tell me what is the difference between air and liquid pressures? Who raised the hand? I will give extra bonus score. How, please? Yeah, and liquid is incompressible. Yeah, 1 point for Miss Yu Ling Yu. She answered correctly one of these factors to these two pressures. And what about density? Oh, please. Okay. You mean air weight lower? What is the density differences between air pressure and liquid pressure? Oh. Okay, yeah, you're correct. And who else? Can someone tell me what is the unit of these two, air pressure and liquid pressure? Yeah, correct. And what else? Yeah, you? Yeah, Pascal, megapascal, kilopascal, kilogram per meter square. all correct. And lastly, what about transmissions of pressure? Can anyone tell me what is this? I think this one of the hard question for these issues. So I'm going to tell you about the answer. So for air pressure, it has lower density, it is compressible, and its variability with depth, no. The unit mostly is atmosphere, millimeter, mercury, Pascal, kilopascal, megapascal. And what is transmission of pressure? Which means, pressure is kind of like vector, so it has many directions, multi-directions. So for air pressure, the transmission of the pressure will be faster compared to liquid pressure. Since liquid pressure is have a higher density, so it's weight more than the air pressure. So the transmission of pressure will be slower compared to air pressure. So these are the table differences between air pressure and liquid pressure. And moving next to this pressure gauge, as you can see from this air compressor pump, we have an instrument. It looks like this. And how do you look at it? How do you know which pressure it is? So as you can see from here, it has red numbers. It has red scale and black scale. And each scale have different units. For the black scale, it is kilogram per centimeter square. And for the red scale, it is PSI. It's a British unit about pressure. So just like you using a ruler, so the ruler will have some big number here, and each big number it has some small scale between each big number. And moving on to the electromagnetic valve. So someone call it electromagnetic valve, someone call it solenoid valve. So on your each group, we have already give you something looks like this one. Do you see it on your table? Your table doesn't have it, but behind you, we have it. So let me give you a short introduction about this one. So this is what we call solenoid valve or electromagnetic valve. So this component, we divide it into two parts, the black one and the yellow one. The black one, we call it solenoid, and the yellow one, we call it valve body. So inside this black one, it will look just like this one. So if you cut this one into half, it will look like this. And let's see what inside the black one. Inside the black one, we call it solenoid. And inside the solenoid, as its names represent, it has a coil of wires. This yellow thing is wires. And in this one is a coil of wires. And in solenoid, we have two coil of wires, which give electromagnetic when there is an electrical current coming. So the black thing is the piston. What is the piston do? It's the piston, as you can see from here, this is what we call orifice. Orifice going to let the liquid or the air coming from this side going through here, and the piston going to block it, either block it or open it. So how it works, we're gonna find it later. And the piston will be pushed by the spring. So the spring, after it receives a signal or an electrical current, the electrical magnetic will make the spring going to push upward, or push downward or lift upward, so that the piston either block the orifice it will either block the orifice or either open the orifice so that the liquid or the air can flow to the other side. So is it clear enough? Oh, one more thing. So the lead wire. So normally the wire will be made by ferrous metal. It could be bronze, silver, gold, or lead, anything metal as long as it's a metal component. So here's a short introduction about electromagnetic valve. It has two port inlet and outlet. And the flow directions, as you can see from this one, if you look it in the bottom of it, it has arrow directions. And this arrow direction will show which port is the inlet. So as you see from here, on my left-hand side, there's a blue wires. And from my right-hand side, there will be a blue arrow coming in. So it represents this one is inlet and this one is outlet. And from this side, you can see the maximum unit of air or water this valve can handle. For example, for this one, it can handle for 16 kilogram per centimeter square. And for the water is 13 kilogram per centimeter square. And the orifice of this solenoid is 3 millimeters. Yeah, that's it. One more thing about this solenoid is when it's in the energized sorry, the energized state, a normally open valve is open or a normally closed valve is closed. So for there it's some kind of solenoid which is in a rest state, it's normally open. So when you give electrical current, the spring will lift upward the piston so that the air coming through it. Or in a rest state, the valve it's in normally open so that when you give electrical current coming through it, the spring will push the piston through it so that it can block it. So we normally have two types of solenoid valve. The one thing is normally open, and the second thing is normally closed. That's all. So here are some advantage and disadvantage of electrical magnetic valve. Why do we use it? First advantage is fast response. When you give, as you know that electrical current is really fast, right? You cannot look it by your eyes. So when you give electrical current coming through it, it will immediately react to your signals. So it will immediately open or close based on what you give. And remote control, because it is it's right now we are in industry 4.0 or 5.0. So we require something that we normally not use human force or use human time to use it. So we always using computer to control it. So for example, my house, I apply this one into my house so that whenever I come home, I can smell a really good fractions in my home. So I'll use this one to control what time it should turn on the fractions in my house. So I can use it to remote control. And thirdly, the third advantage is reliability. Normally, this one, it could use up to 5 or 10 years. 5 or 10 years compared to the normal valve. So currently, this one is really common in industry. And lastly, the last advantage is simple. It is a comparatively simple structure. It only have two body, this one and this one. And the disadvantage of the electromagnetic valve is limited pressure and flow range. As you can see, it's pressure only up to 16 for the air, 13 for the water. So compared to the ordinary valve, the pressure unit is kind of low. So the normally valve without the solenoid, it could up to 100 or 50 kilogram per centimeters square. And when we use it one, it's kind of noisy and it's vibrate a lot. So those two are the biggest disadvantage of this thing. And lastly, fail-safe concern. Since this one requires electric, so we don't know how to prevent it from safety for the user. Sometimes this wires it broken somewhere, and if someone touch it, they can get shocked by electric, right? So those three are the most disadvantage of the electrical magnetic valve. So moving on to relays modules. As you can see from your table, we have something looks like this. Oh, shit. It looks like this one. You can open it to see the inside. Thank you, TA. So you will see your electrical devices like this one. Electronics. If you have opened it, you can tell me. So you guys have taken it out yet? Already, right? So you can put your relay in this direction so that it can look like this. So so on your hands, we have a relay modules, which has 4 relays. And which one is relay? This little blue guy here is a relay, a single relay things. And one relay, we have 3 ports. This one, and this one. So these 3 ports, we call it, we give it a name: normal open, common port, and normal closed port. And in below this relay, we have giving it a number. So looking from your left hand side, it's number 4, number 3, 2, and 1. And looking from the top of it, this thing we call it GPIO pins. And this GPIO pin will giving the signal to this relay. And on the outer left hand side will be VCC. On the right will be GND. And from left to right, it's 4. This one should be 4. Yeah, this one should be in 4, 3, 2, 1. I think I miswritten it. So if you want to connect to a specific relay, you can wires. For example, if I want to connect my devices to port to relay 3, I need to connect the wires to normal open or common port. Either you choose normal open or normal close, but the common port you always need to connect it. So normally we only use it two out of 3 ports only. And if I want to connect with relay 3, I need to giving an electrical inside here and route wires, and then I choose 3 in here. That's it. So this is the introduction of relay modules. You can read it from this one. A compact and pre-assembled circuit board that includes one or more relays along with supporting components. So normally when we use relay, we can connect it with transistor, diodes, or optocouplers so that we increase more the safety concern for our electrical circuit. But today we won't do any transistor because after our experiment, we find out we don't need these 3 things to increase the safety because relay itself, it's already safe enough for you to use it without a transistor. And relay modules, it's a simplified iteration of electronic projects. If you do some related to robotics projects, we normally see this guy coming in. And relay modules, it can vary in many circuits. It can be 3 relay modules or 2 relay modules or 4 relay modules. And the maximum number relays on a module I saw is 16. And I will let you see how the relay works. Oh, shit. Oh. How do I zoom it? See.
Side, secondary side. The primary circuit provides the control signal to operate the relay. This can be controlled by a manual switch, a thermostat, or some other type of sensor. The primary circuit is generally connected to a low voltage DC supply. The secondary circuit is the circuit which contains load which needs to be switched and controlled. When we talk about a load, we need any device that will consume electricity, such as a fan, a pump, a compressor, or even a light bulb. On the primary side, we find an electromagnetic coil. This is a coil of wire which generates a magnetic field when current passes through it. When electricity passes through a wire, it creates an electromagnetic field. We can see that by placing compasses around the wire. When we pass a current through the wire, the compasses change direction to align with the electromagnetic field. When we wrap the wire into a coil, the magnetic field of each wire combines together to form a larger, stronger magnetic field. You can control this magnetic field by simply controlling the current. By the way, we have covered how solenoid coils work and even how to make your own solenoid in our previous videos. Do check that out. It can be found in the video description down below. At the end of the electromagnet, we find the armature. This is a small component which is pivoted. When the electromagnet energizes, it attracts the armature. When the electromagnet is de-energized, the armature returns to its original position. Typically, a small spring is used to achieve this. Connected to the armature is a movable contactor. When the armature is attracted to the electromagnet, it closes and completes the circuit on the secondary side. We have 2 types of basic relay, the normally open and the normally closed type. There are other types of relays, and we're going to look at these a little later in the video. With the normally open type, no electricity flows in the secondary circuit. The load is therefore off. However, when a current is passed through the primary circuit, a magnetic field is induced in the electromagnet. This magnetic field attracts the armature and pulls the movable contactor until it touches the terminals of the secondary circuit. This completes the circuit and provides electricity to the load. With the normally closed type, the secondary circuit is normally complete, and so the load is on. When a current is passed through the primary circuit, the electromagnetic field causes the armature to push away, which disconnects the contactor and breaks the circuit. This cuts the supply of electricity to the load. The operation of solid-state relays, or SSRs, is similar in principle, but unlike electromechanical relays, it has no moving part. The solid-state relay uses the electrical and optical properties of solid-state semiconductors to perform its input and output isolation as well as switching functions. With this type of device, we find an LED light on the primary side instead of an electromagnet. The LED provides
我们的散热音机还可以应用。那我拿到公屏，然后那待会我给你一个答案，可以帮我去印。
This type of relay by simply turning the LED on and off. The phototransistor acts something like an insulator and doesn't allow current to flow unless it's exposed to light. Inside the phototransistor, we have different layers of semiconductor material. There are N-type and P-type, which are sandwiched together. The N-type and P-type are both made from silicon, but they have each been mixed with other materials to change their electrical properties. The N-type, P-type have been mixed with a different material that has fewer electrons. But this side has lots of extra space, so electrons can move too. When the materials are
Sorry. Sorry. Don't worry. Wrong keyboard.
nanoparticle known as a photon. The photon hits the P-type material and knocks the electron, pushing them across the barrier and into the N-type material. The electrons in the first barrier will now be able to also make a jump, and so a current is developed. Once the LED is turned off, the photon stops knocking the electrons across the barrier, and so the current in the secondary side stops. So we can control the secondary circuit just by using the beam of light. Many types of relays. We're going to now consider a few of the main ones, as well as some simple examples of how they are used. Let me know in the comment section how and where you've seen relays used. Or even better, tell me what ideas you have for their application, or any project you're working on, where they could be applied. As we have seen earlier in this video, we have the simple normally open relay. This means the load of the secondary side is off until the circuit is complete. We can use this, for example, to control a fan by using a bimetallic strip or switch on the primary side. The bimetallic strip bends as it increases in temperature. At a certain temperature, it will complete the circuit and turn the fan on to provide some cooling. Also find on the closed relay. This means the load on the secondary side is normally on. We could, for example, control the pump system to maintain a certain water level in the storage tank. When the water level is low, the pump is on. But as it reaches the limit we require, it completes the primary circuit and pulls the contactor away, which cuts the power to the pump. Extended normally open relay, once the primary circuit is re-energized, the electromagnetic field disappears, and the spring pulls the contactor back to its original position. But sometimes we want the secondary circuit to remain live after the primary circuit is reopened. For that, we can use a latching relay. separated circuit that piston mixes between them. First circuit is the call button, second is the lamp, and the third is the reset circuit. When the call button is pressed, it completes the circuit and powers the electromagnet. Hold the piston completes the circuit to turn the lamp on. The signal is also sent to the elevator controller to send the elevator down. The button is released. This cuts the power for the initial circuit, but as the piston isn't loaded, it stays in position and the lamp remains on. Once the elevator car reaches the lower floor, it makes contact with the off switch. This powers the second electromagnet and pulls the piston away, cutting the power to the lamp. Latching relays therefore have the benefit of having positional memory. Once activated, they will remain in their last position without the need for any further input of current. Relays can have single or double poles. The term pole refers to the number of contacts switched when the relay is energized. This allows more than one secondary circuit to be energized by a primary circuit. We could, for example, use a double pole relay to control a cooling fan as well as a warning light. Both the fan and the lamp are normally on, but when the bimetallic strip in the primary circuit gets too hot, it bends to complete the circuit. This creates the electromagnetic field and closes both contactors on the secondary side. This provides power to the cooling fan as well as the warning light. When dealing with relays, you'll often hear the term throws. This refers to the number of contacts or connection points. A double throw relay combines a normally open and a normally closed circuit. A double throw relay is also called a changeover relay, as it alternates or changes between two secondary circuits. In this example, when the primary circuit is open, the spring on the secondary side pulls the contactor to terminal B, powering the lamp. The fan remains off because the circuit is not complete. When the primary side is energized, the electromagnet pulls the contactor to terminal A and diverts electricity, this time powering the fan and turning the lamp off. So we can use this type of relay to control different circuits depending on an event. The double pole double throw relay, or DPDT, is used to control two states and two separate circuits. Here we can see a DPDT relay. When the primary circuit is not complete, terminals T1 and T2 are connected to terminals B and D respectively. The red LED and the indicator light are energized. When the primary circuit is closed, then T1 and T2 connect to terminals A and C. The fan turns on and the green LED is also energized. Something you need to consider when working with electromagnets is the back EMF, or electromotive force. When we power the coil, the electromagnetic field builds up to a maximum point. The magnetic field is storing energy. When we cut the power, the electromagnetic field collapses and it releases the stored energy very quickly. This collapsing field continues to push the electrons, and this is why we get the back EMF. This is not a good thing because it produces a large voltage spikes which damage our circuit. To overcome this, you can use something like a diode to suppress this. The diode only allows current to flow in one direction. So, in normal operation, the current flows to the coil. But when we cut the power, the back EMF is going to push the electrons. And so the diode will now provide a path for the coil to dissipate its energy safely so that it doesn't damage our circuit. Okay, that's it for this video. To continue your learning of electrical engineering, and check out one of the videos on the screen now, and I'll catch you there for the next lesson.
Okay, so one small questions. Which keywords or which word do you usually see or you normally heard from this video? Raise your hands. Which keyword you usually heard from this video? Yes, correct. Give her an extra bonus point, TA. Yeah. So from this video, so you can point out that the similarity between solenoid valve and relay module is both are normally open or normally closed, and the working mechanism between these two devices are almost the same, but a little bit differences only. So I hope from this video you can know that the solenoid it's also work the same with the relay. And okay, moving back to this thing. So before coming to electrical circuit, I want to ask you guys, does anyone here have the experience with Arduino? One, two, raise your hand, raise your hand. The raise shirt, 3, 4, 5, 6, 7, 8. Okay, so most of you have know how to connect the Arduino to the breadboard and also the devices. So I will go through it quickly. So here is our simple electrical schematics. First, we connect the air compressor pump with the electromagnetic valve. And from this valve, we would be, so in here would be the inlet port, and this one will be our outlet port. And the outlet port will be connected to our soft robot. And from the solenoid valve, we have two wires. So one of it will be connected to our power supply, which is 110 voltage. And the other wires will be connected to the relay. And from the relay, you can connect it to the Arduino board. You can use the USB to connect with your PC so that it can work with the wires. Or we also give you guys the power batteries. So you can use battery to give in power to the Arduino to make all the schematic or the circuit have works. That's it. So if you have any further question, you can ask us in the afternoon or in the morning, because today we intend to let you guys have more time discussion on the design part, and the control part you can ask us this afternoon or next week, next Monday. It's fine. So moving to the Arduino. So I think you guys all know about the Arduino programming. So I will go quickly. Voice setup and void loop. These two are the most frequency in the Arduino. And these two are functions. And voice setup is the first function to be executed in the sketch. And the void loop will be a function that execute identically until you power off the Arduinos. So which means anything you written in this function, it will continue working, continue to operate until either your power supply ends or Arduino board is broken. And I think if you can see from my PPT that I have written, I have assigned a solid point pin for the number 4 pin in Arduino port is for solenoid. And I continue to since I assign this one in here, so I need to put it into the setup. And continue to be from the setup. If I want to open the relay, I will let it open switch on the relay for 1 second. And after 1 second, I will turn it off. That's it. So simple programming, I don't know, code for this guy today. That's it. So you guys can have times to practice Arduino programming today. If you have any questions, you can ask us. Thank you. Anyone here doesn't know how to use the function in Arduino? Who cannot write Arduino programming? Raise your hand. So I guess everyone here does know the basic code of Arduino. It's really, really simple. So yeah, forgot to mention, this 13 line of code only for one relay. So if you use more than 2 or 3 relays, you need to add more in here and then more in here. You got it? I think you know it, right? So that's why this is just an example for one relay control. I don't know. Oh, why do we need to write an output in this pin mode? Anyone?
I don't know if you learned Arduino code before or C program before. If you do, if you did, yeah, sorry, you can understand or what I'm talking about, or you can answer my question.
Extra point.
Extra point, okay, extra point. Or such as what's the meaning for high inside the C program? Anyone answer that?
Yeah. Almost really correct.
I believe most of you understand how to write a
Because we want to let them discuss the 3D design first, because this part needs to work with their soft robot. If they have the soft robot, they can use this one to connect with their soft robot. But if they don't have the soft robot, they do this thing is meaningless. That's
number for the shape will be important. This is kind of like a frequency. They need to talk to air to the computer.
yeah.
So probably we can still try to write a program and then connect some air tube to the relay and see if you see the program will go. Hey, right.
Okay. Sure. So you guys can have time discussion how to write your coding for your soft robots. You can use as many solenoid pin as you want, as much as long as it can work with your soft robots. Team discussion time.
Yeah. So he asking why module have four relays. because it is.
地方也是 model。
So we only
We have a smaller one. We
We have
only have a
smaller
one relay, but in
So-
this board we have four relays.
for example,
This is different board.
do we need 4 relays? You can use 1 relay. Because you know that's what. Yeah, we use 1 relay.
But
This 4 relays.
But actually it depends on how many air pump you need to use.
So each relay corresponds to 1 air pump.
Yes.
So if you use 3 air pump, you have to use 3 relays. So I can control each air pump like independently.
Independently, yes.
Or at the same time.
Yeah.
The reason why it is 4 relays, so it's saving space. So we can do up to 4 air pumps. Yeah. Right? It depends on your design. So we can even like you have 5 pumps. Yeah, if you have 5 pumps, you need to manufacture a relay. Another relay. Yeah. It's still doable. It's still doable, right? Yeah, it's still doable.
Respond。
Okay. Ready for this one? What do you say?
没有，我只是在想那个单词。
It's okay.
放轻音乐，或是放英文吧，不要放中文，放英文也可以。
Nó là kiểu nghe này nó sẽ nói là chương 1 đến 2 lần đúng không? Mình muốn kết nối cái mình muốn xài cái gì đây hai mình kết nối gì này vô hai vô một trong cái cổng digital pin nào đó ở đây cho khai báo ở trong đúng rồi ở cái cổng này luôn nếu mà khai báo được 4 đây đúng không? Cổng 4 rồi nữa cái nó sẽ tự sao đúng rồi mình hay chỉ cái độ mạnh của cái tam tâm đúng không? Hôm qua tôi thấy mấy ông chụp tay cái bàn tay tại vì giống như là thấy trong video cái relay này có nghĩa là cái switch nó chỉ switch cái này nó không có đúng không đúng chuẩn đúng không? Cái này cũng là cái switch mà cả hai cái này là cái switch là cái switch để tiếp lưu đi qua cái switch để thay vì phải là như này thấy được là có cái công tắc có thể là rồi cái cũng còn không công tắc mà cái phần có relay rồi cái relay này sẽ điều khiển cái relay bằng này đúng không? Đúng rồi, bằng code đó là tự động hóa. Người ta không dùng switch trực tiếp từ cái này vào cái này luôn, người ta tiếp trực tiếp. Bởi vì cái này là cái hai power hai voltage lại cái nói một trăm mười một còn cái này là biết là nó tối đa là đây là cái nói là cái đường này nó là 17 con chuột mạch năng lượng con chuột cái cục hai voltage không được gì cả.
有时候他们今天早上，然后给他们弄。
太多人，那你走吧。
你有事要说。
那我留个